This is question 12 from the second CSAT sample paper. Here we're told that the coordinates cos t sin t trace out a unit circle. If we imagine t is time, so this is increasing, traces out a unit circle. And we're asked to make this spiral that starts at the origin and then crosses the x-axis at 1, and then at 2, and then at 3, etc. And we're asked for it to cross when the time is 2k pi. So, for instance, it crosses at 1 when t is equal to 2 pi, at 2 when t is equal to 4 pi, etc. And we're asked to find the speed of a point on this curve as time goes by, if you imagine a point tracing out the curve, or an object tracing out the curve. So if you want to have a go at this question yourself, pause the video now. Okay, so first things first, what coordinates do I want to write down? Well, it's going to be something similar to this, or they wouldn't have given this. Why does this work? It's because the x-coordinate is going from positive to negative and then back again, and the y-coordinate is doing the same, but they're not quite in sync, so it's not doing this. As the x-coordinate decreases, the y-coordinate increases, so it does this. And also, if we think about the distance of this from the origin, distance of this point from the origin, it's just the square root of x squared plus y squared, which is cos squared plus sin squared is 1. So this is always at a distance 1 from the origin. So let's use the cos t sin t part to make it go round and round. But we also want to increase the distance from the origin as t increases. So a promising idea might be to multiply both of these by t, do t times cos t and t times sin t, because then it's going to go round and round and it will move outwards as t increases, and it will start at 0. But does it cross the axes in the right places? When t is equal to 0, it starts here. It's going to be here when t is equal to 2 pi, because then x is 1. It's going to be along here at least, because then cos of t is 1, sin of t is 0, so it's going to be in the positive x-axis. But if we made it t times cos of t, it would cross at 2 pi. And we don't want it to do that, we want it to cross at 1. So we need to divide by 2 pi. So our answer is going to be t over 2 pi times cos of t, t over 2 pi times sin of t. So because of the cos and the sin, it goes round and round. And then let's check when t is equal to 2k times pi, cos of that is 1 and sin is 0. So this is 0, it's on the x-axis. And t over 2 pi is going to be k, so it's going to be plus k when t equals 2k pi. That's exactly right, so this crosses in the right places. So now we just have to find the speed for the points tracing out this curve. So how do we do that? Well, what is the speed? It's the derivative with respect to time. And that might look difficult to work out because we've got two coordinates here, which is the derivative of. You might be tempted to think, well, we'll find the distance from the centre and we'll take the derivative of that. But that will only measure the speed outwards. But suppose we're travelling like this, then we might be moving outwards, but we're also partly moving tangent to the centre. So not all of our speed is going out from the centre. I mean, for instance, if we're just moving in a circle, then we have a speed, but we're not moving outwards at all. So you can't just find the distance from the centre and then differentiate that. So the way to think about this is to think we're working in 2 dimensions, and therefore the speed has vertical and horizontal components. If we could find those components, we can find the total speed. What's the horizontal component? It's just the rate of horizontal change in distance. So that means it's the rate of change of x with respect to time. So that means it's just dx by dt. And likewise, the vertical component is going to be dy by dt. So we'll find the horizontal and vertical components, and then we'll find the speed from those. So dx by dt, what's this going to be? The horizontal component dx by dt is, well, we'll use the product rule. So first we differentiate t, keep cos the same, so 1 over 2 pi times cos of t. I could have taken 1 over 2 pi out of the whole thing. And then we keep this part the same, we differentiate cos to minus sine, and that gives us this term. And then for dy by dt, it's going to be similar, but with sine instead of cos. So first part we have sine instead of cos, and then when we differentiate sine we get plus cos, so we get this term. And now we want to find the speed from those. These are the sizes of the components. So if we square these and add them together, we get the square of the speed by Pythagoras. So v squared is dx by dt squared plus dy by dt squared. And now I'll take out the 1 over 2 pi and square it, so I get 1 over 4 pi squared, and I'm squaring everything else. So when I square this first one, dx by dt, I get cos squared. Remember, I'm ignoring the 1 over 2 pi. And then minus 2 times t times sine times cos. And then plus t squared sine squared. And then similarly for the second one, except I have sine squared, this becomes plus 2 times t times cos times sine. And this becomes t squared cos squared. And now we can see how this will simplify. These middle two terms cancel. Cos squared plus sine squared is 1. And here we've got t squared times cos squared plus sine squared is just t squared. So we get 1 over 4 pi squared times 1 plus t squared. And now we can square root it. So we get root 1 plus t squared over 2 pi. Bear in mind we can take the positive square root because it's the speed, so it's positive. So this is our answer for the speed, and that's the end of the question.